thank you so much for staying with me until the end of the conference. My name is Edson Yanaga. I'm the lead DevRel for Google Wallet. And today we're going to be talking about revisiting design patterns after 20. And why 20? The committee asked me, isn't it Java 20? And I said, yes. But that's just because I'm very bad at puns, because I wanted to say, well, it has been more than 20 years since the release of the original design patterns book, and we also have Java 20 now. So I wanted to make this pun, but apparently it was a very bad one. And as I said, English is my second language. Well, sometimes it just doesn't work. So, and most of the content related to this talk came from the original book. It has been, I believe, 20 was 1994, 16, 23, almost 40 years, is that? No, 30, almost 30 years of the release of the book. So some of the content is outdated, some is not, but the ideas are here to stay. Also, I took some ideas from the domain-driven design book. And why not? Effective Java. I also have a talk about revisiting effective Java. We should talk about the latest and greatest features of the last version of the book. And I'm going to reuse some of these concepts in this talk. And Java 20 was released on March 21st. So it has been a couple of weeks since we had the latest and greatest version of Java. How many of you are using Java 20 already? Thank you, Barry. Yeah. So at least one person. Java 17. Oh, I'm surprised. Yeah, I wasn't expecting that much. Java 11. Okay, some of you are using more than one version. Okay. Java 8. Yeah. 7. Yeah, sorry. Yeah. So we have a lot of people that are able to use some of the latest versions of Java. So some of the tips here might apply to the latest and greatest version of Java. Some of these tips might apply to if you're using Java 17. But I think most of them you can use if you're using at least Java 8, because lambdas change the way we see the word when we're coding. So Java 20, the latest version. And when we're talking about design patterns, I'd like to emphasize some words from this quote here. A design pattern is a general, reusable solution to a commonly occurring problem within a context. So trying to apply a design pattern without a context is basically useless. It's basically what you do when you're like an undergraduate student and you learn about design patterns. Oh, it's so cool. I want to add it to my code. Yeah? You're just trying to add problems to your code because you don't have the context. So if you find the right context and you find the right problem, maybe you can find the right design pattern that is the perfect solution to the problem that you have in your hands at this moment. But for the discussion of this talk, I think the most important feature of design patterns is that having design patterns allow us to have a pattern language. So if you go through the design patterns, if you read any design patterns book, you learn, well, what is a strategy? What is a template method? What is a visitor? What is an observer? What is a command? And when you have to explain or you have to discuss some solutions with your colleagues at work, you don't have to explain to them, well, actually, I wanted to do some polymorphic stuff where when I change the type, I might be able to change the code that I'm going to be executing at runtime. You don't have to explain all of this stuff. You just have to say, well, this particular problem, well, we might use a strategy for this. Okay, and you use the same pattern language over and over. It eases the communication between your colleagues, and we'll try to explain some solutions and some problems as well. And some guiding principles that we have when we're trying to apply these new or modern or revisited versions of design patterns in 2023 or after Java 20 are, first, favor composition over inheritance. So this is a guiding principle that we've been using in the past at least 20 years, and we're going to still keep using. This one I took from the original design patterns book, okay? Favor composition over inheritance. Another one, favor smaller interfaces. You might have heard it as the interface segregation principle, which is from a book you might have heard about. Okay. And also the last one, favor existing interfaces from Effective Java. So instead of creating your own interfaces every time, I know you want to give more semantics, you want to give a meaning to the particular interface that you're using. But since Java 8, we have, I believe, almost 40 new interfaces, new function interface that we have in the JDK. You don't need to add another one that is doing exactly the same thing. Remember? Pattern language. If you're reusing an existing interface that every Java developer should know, because it has been years since the release of Java 8, you ease the communication between your colleagues, between your teammates. So favor existing ones. And based on these guiding principles, these are the design patterns that I wish to revisit today with you. So we're going to be discussing a bit about command, observer, strategy, template methods, singleton, interpreter, chain of responsibility, visitor, and specification. So these are the ones that I intend to cover today. Let's start with command. Command, I took the simplest ones. Command is the simplest one because you might be tempted. If you read the design patterns book and you want to implement the command design pattern today in your code, you might be wondering, well, why don't I create an interface, public interface command? This is a function interface because it only has one abstract method, and it's going to be void execute. This is the method that I have. Well, don't do that because we already have an interface in the JDK that fits the exact same purpose, which is runnable. So don't create a command interface. Use runnable because everybody knows what runnable does, and it has exactly the same signature. Okay? Same principle applies if you want to create an observer pattern these days. The original observable implementation from the JDK, it has serious issues. It has been deprecated since Java 9. So instead of relying on the JDK implementation of observable, you should be implementing your own. What were the issues before? Well, the JDK implementation wasn't thread safe, didn't have a guaranteed interaction order, and it didn't have generics and other problems as well. So if you're implementing the observer in 2023 after Java 20, you should instead of creating an interface, public interface observer of type T, and void notify receiving that particular type T in this event, you should what? Well, reuse an existing interface. And we have the same interface in the JDK, which is consumer. Consumer of type T, which accepts an argument of type T. Well, this is the observer part. What about the observable? Well, you can implement the way you want. You can implement with a list, you can implement with a map, you can change in direction order. It's up to you to implement the observable part. Okay? So you have more flexibility when you're implementing the design pattern. And these are the simplest ones because it only involves a simple function interface. Now let's try to do something more complex. Let's talk about the strategy design pattern. So if I move here to the code, the legacy way for me to implement a strategy is like this one. So here I have some sample code. And in strategy, usually when you're creating your abstractions, use strategy because I want to change a particular implementation. For example, here in my code, I have a Google Wallet endpoint, and you would learn that there are different ways for you to add to Google Wallet links if you want to add passes to your Google Wallet. So you can create like a full sign jot, or you can create I'm lacking a better word, but we have the fat jot and the slim jot. The fat jot contains the entire pass information, and the slim jot just contains the IDs because you already pre-created that in the API. But these are two different ways for you to create a pass in the Google Wallet. So you create it here, and you added the strategy as a pluggable interface. So how would you implement a strategy? Well, I create an interface. This interface has one method. string create link, you add the pass information, and you receive the link for people to add that. And you have two different ways of implementing that, which, of course, I didn't implement. I just created two separate strings, a jot with a complete information and a jot with just the IDs. This is the legacy way for us to be creating the strategy. But if I wanted to do this the Java 20 way, you might have seen this in Effective Java, for example. So it is not even a novel way for me to implement that. So I have the Google Wallet endpoint, and instead of creating another interface, I could, it's tempting. Well, I know that if I look here at the legacy code, I notice that this add to Google Wallet strategy is getting a pass information and returning a string. Of course, this interface is a function. Okay, it's receiving something and transforming that into another thing. So it's tempting for you to do this. You might create, well, interface and add to Google Wallet strategy and extends a function which receives a pass information and returns a string. Tempting, right? The problem is that every time a developer sees your code with an add to Google Wallet strategy, what is an add to Google Wallet strategy? They have to go through the source code and see, oh, it extends a function with these two different types on it. So don't do that. Whenever you're tempted to create a new interface, simply don't. Reuse the ones that you already have. Remember, pattern language. You want to reuse the knowledge between the Java developers that you have in your company, in your team. So I'm not going to create a new interface. I'm just going to reuse the one I have, and I'm going to create here a function that it receives a pass information and receives a string. And this one can be the function. I can set this one and execute. So, and now I have my endpoint, Google Wallet endpoint. How do I provide the implementation strategy here to my code? So now when I want to use this strategy, if you have simple one-liners, I could do this. Well, I have the Google Wallet endpoint set function, and I could say, well, here I have the pass information, and I want to implement that. Well, I'm just going to return a static string. This is my default implementation. Okay? Which is pretty cool when you only have a one-liner, but more likely than not, your code will require a lot of lines of code. So instead of using one-liners with a lambda, you should use a method reference. So I'm just going to copy-paste the code that I have here. Suppose that you created a class with the different types of implementation. Okay? It's up to you if you want to separate that in different classes or not. And if I move here and create a class, add to Google Wallet link. These methods in particular, because they don't have state, they could be static. And I'm just going to leave both implementations here because you can see the difference between them. Instead of doing this, I could use this method that I have here. So because they would have a pass information, look at the signature. It doesn't matter the name, just the types that I'm receiving. I'm receiving a pass information and returning a string. So I could do what? I could call this class, add to Google Wallet link, and call complete. Right? I'm using a method reference. I want to use this particular static method, so I'm using a static method reference. But this other one, this is my default implementation, and I want to use this other method, pre-created one. Well, this one is not static, so it's an instance method. I need to pass an instance. Very likely I would have instantiated it before, but just in case I didn't, I could use add to Google Wallet link, and from this instance, I could use pre-created. Okay? So you have like big implementations, you just create another class with the same method signature, doesn't matter the name, just the types, and you reference them. This is the modern way of you to implement, this is the modern way for you to implement the strategy design pattern. Okay? So strategy is very likely the most common design pattern of all. 90% of the time you'll be using the strategy. Another one that is not so uncommon, and it's the next one that we're going to cover, is the template method one. And I crossed this one because template methods are deprecated. You shouldn't be implementing template methods in Java 20 or in 2023. So what could we do here? So the legacy way for you to implement the template method is that when is it useful? Well, suppose that you have a certain code and you have different implementations of that. Sounds like strategy. But actually, instead of just being in a strategy, you have a piece of code that needs to be always executed before the piece that changes, and you have some other piece of code that always needs to be executed after the part that changes. So in the legacy design pattern, you would create what? You would create a method here. For example, I'm saying that for you to create a pass, first you need to authenticate. Then you need to create a proper pass because you have multiple different types of passes. And then you need to sign the JOT with your private key to be able to give the link to the user. So the first and the last step are always the same. What changes? Well, what changes is the actual pass creation. So this is the implementation of a template method. You have the first thing, you have the last thing that you do, and you have the thing that is going to vary between implementations. For this piece, you create an abstract method. And then you subclass this class, you create your concrete implementations. Here I have a loyalty pass creator that returns a map with loyalty. I'm loyal. And I have here an event tickets pass creator which returns other information. Okay, so you have two separate implementations, but the first piece of the code and the last piece of the code is always the same. The problem is that you've seen that it's cumbersome for you to be creating these abstract classes, abstract methods, and implementing that. The modern way, the revisited way for you to be creating template methods is to not create the template methods. So what can we do here? Let's copy this code here. So suppose that I have this legacy template methods here. I'm going to copy these codes into my new class. I still have authenticate. I still have the sign token code, but this particular thing changes between my implementations. And look at the signature of this method. I'm receiving a pass information and I'm returning a map of string and string. This is again a function. So the modern way for you to implement the template method is by replacing template methods with strategies. So what do you do here? Instead of subclassing, you receive the strategy as a parameter. So I'm going to create a private final. I'm just going to use our private function, which receives a pass information. Oh gosh. Pass information and returns a map of string, string. And I can even say this is my strategy. So when I do here, I just do strategy dot apply, and I have the pass information. Okay, and I remove the abstract here. Doesn't need to be an abstract class anymore. I just need to be able to set the strategy of my class. Okay, or even better, if you're not a fan of setters, I'm not. So an even better way for you to be doing this is by creating a final fields and creating a constructor with the parameters that you want. So now that you're using it, I can just do this. I can create a new Google Wallet pass creator, and I could pass the implementation, the strategy that I have here. I create a P, I have the pass information, and return a map of event ticket where I'm going, or just like the strategy example that I've shown you before, you would use a method reference if it's more than one liner. So template methods, don't use template methods in 2023 or after Java 8. You should be using strategies. Next one, Singleton. This is pretty straightforward, the legacy implementation of Singletons. If I can scroll here, is you would very likely create a private static final instance here. You would pre-instantiate, you would instantiate it in a lazy way, but no matter how you created the instance, you would just have a method get instance and return the instance that you have. The problem with this instance is that it doesn't work with serialization. It's not synchronized as well. So you will need to add some serialization code to work when you have this particular use cases. So if you want to implement the modern version of a Singleton, and you're not using a dependency injection framework, instead of creating a class, you just create an enum and declare it as the only instance of your particular enum. This way, you don't have any serialization problems because the JVM is going to take care of everything. And since enums in Java are full-featured classes, you don't have to worry. You can code like it was a class. You can create fields. You can create private fields. You can create methods. You can do everything in your enum. Okay? This is what you do. And in fact, enums before lambdas, they were by far my favorite feature in the Java language. So this is how you create enums. Next one, interpreter. Interpreter, I'll admit, it's very rare for you to need to create an interpreter. But when you do, you do. And I'm going to show you how, because it's very different on how we can create an interpreter these days. Let's go back here to the code. And if I get my interpreter, the legacy one is this one. Okay? I have an interpreter, and every single example in the internet is going to show you a reverse Polish notation for it to create an interpreter, which is a weird way for you to implement a math operation, but it's super easy to implement, the parser. So that's why everybody does that, because the focus is not on the language that I'm creating, but on the steps on how to interpret that. So here I have my expression, and here I just implemented this one. The legacy one is going to be much more complicated than this, but I used the Java 8 Plus version of this particular interpreter. Okay? So let me try to work on this one. So when you have an interpreter, first, in the very old implementation of the original Django 4, you will need to create classes for each one of those operations. You will need to implement an add operation. You will need to create a subtract operation. You will need to create an integer, like a number, expression, so you could compose your language and then evaluate your expression. The Java 8 version, actually the enum version, the Java 5 plus version, would ask you to create enums for your operations. So here I have add and have subtract. And how would I do that? Well, I very likely would say, well, each one of those operations, they have a method, which could be public int evaluate, which they receive an x, int y. And not only I would have this implementation, but it would be abstract, which means that I would have to implement in the enum. Remember that I said that enums are full-feature classes? They can do almost everything. Well, you can, guess what? You can implement these methods in the enum. So the add, I'm going to extend here the implementation of the enums. So this one, add, is going to be x plus y. Okay. But because of the way we're using reverse Polish notation, so actually the stack is always going to be inverted. So it needs to be x plus y plus x. Okay, you forgive me? But it's just because of the way that he implemented x, y minus x. It's just the way that I implemented the interpreter. So you have here add is going to add, subtract is going to subtract. If you have any other operations, just a matter of adding another enum and doing that. Once you have here, how do you interpret here in this language, reverse Polish notation? How do I interpret this plus and this minus sign? I need to have a function that gets this particular character and returns the corresponding operation. Okay? How can I do that? Well, luckily, since Java 5 Plus, I can do this. I can create a private static final map of a string, that is the string that I'm receiving, and it's going to return an operation. Okay? And how can I call it value map? Okay, and how can I create this map? Well, I need a corresponding string for my particular operation. So I'm going to add a field here, private final string value. And it's going to complain because it's a private field, so I'm going to add a constructor parameter, refactor. Now it does have a constructor parameter, and now it's complaining because I didn't provide a value. Well, let's add here the character. If it's add, it's a plus sign. If it's subtract, it's a minus sign. So it's working. The only thing missing here is my map. And what I'm going to do arrays stream, and I already have a property called values, which contains all the values of the enum, and now I'm going to map. Actually, I'm going to collect them directly, because I already have all the enums, and now I just need to create a map. I'm going to use collectors to immute to collectors dot to unmodified map, because it's not going to change, because the enums are not going to change. First, I need a function that returns the key. Well, the key is going to be the string value. So I have here the enum, it's going to e.string value, and then I have to return the operation by itself, which is going to be e. Okay, I'll return here, and if you're a purist, you might be wondering, well, this is the identity function because it's always returning the same elements. I could implement this way, or I could have implemented it like this way, function.identity. Which one is easier to read? In my particular opinion, is the other version. So I'm going to leave the other one. Okay, so this is easier to read. So I have the map. The only thing missing here is now that I need a method, a public static operation from string value, and I return the value map get string value. Okay, so how do I use this operation for the interpreter? I can do this. Okay, and actually I'm going to copy because I don't want to make mistakes. We create a stack. We go here, recreate the operation from string, and we have two cases here. Once I split the tokens, if I get here, either I get an operation or I get a number. Okay, these are the two possibilities. The code that I have today would require me to do this. I would need to go here to the operation from string. I would need to get it. I would call this operation. If operation different than null, then it's a proper operation. I will need to get the parameters and perform the operation. If the operation is null, means that I didn't get an operation, I got a number, that I will need to just get do this stack.push and push the number. I would have to parse and put there. But there is an easier way for me to do this using Java 8 Plus, because since Java 8 Plus, I have what we call an optional. So if I know that it's possible for me to pass a string and return not an operation, but an absent implementation, instead of just returning an operation, I can return an optional of operation. And how do I do that? I just optional of nullable and return this one. Now my code can be much simpler, because instead of doing the if, I can say if present or else. If present or else, I think it's different. It's recent, actually. And it requires two parameters. First is a consumer, if present. If I have this one, well, I have the operation. So I found the operation. If I have the operation, I'm going to get operation.apply, evaluate. And if I'm going to evaluate x and y, I'm going to get stack.pop. Stack.pop. Okay, I'm getting this. And if it's not an operation, it's just a number, I'm going to get what? I'm going to get one stack.push integer.parseInt s. Okay? This is the implementation of my interpreter. And let's see if I did everything correctly, because I want to run this one. And apparently not. Empty stack implementation. So instead of trying to debug this one, I'm just going to copy paste my stack implementation and do this. Pretend that I did it right in the first time. Okay? Operation from string. Evaluate. Okay, now let's run this. 7. And why is that? 5, 7 plus 12. 10, 5 minus 5. Okay? Then 12 again minus 5, 7. So it's working. Okay? So this is my interpreter for the legacy version. What is the revisited version? Okay? And now I skip implementing because, again, instead of creating strategy with subclassing, I'm using strategy as a parameter. Okay? What can we do? I can refactor the legacy one here. So instead of doing this, you see, well, this is the part that changes. This is what? This is a classic strategy implementation. But in modern version is that I don't subclass things anymore. I pass the part that changes as a lambda, as a function. So instead of creating this abstract method here, what I'm going to do, I'm going to create a private final int binary operator. I'm going to add this to my constructor. Now I have this constructor parameter, and this method is not going to be abstract anymore. It's going to return operator apply as int x and y. Okay, and now instead of subclassing my enum, I don't need to do this anymore. I just pass this operator, which is xy. I return x plus y. And here, I return x, y, and returns y minus x. Okay? So I changed the implementation. I'm not subclassing anymore. I'm using the strategy as a parameter in the constructor here. And the code should work the same. Let's try to run it again. And still 7. So this is the modern version of the interpreter design pattern. Move forwards. Chain of responsibility. This is an interesting one. What does the chain of responsibility do? Well, you have a particular object, you have a type, and you don't know exactly how to handle that particular type. But you have multiple different pieces of your chain, and each one of them can handle that. And the first one that handles it, it just skips the rest of the chain. How does it work? Well, let me show you some code. Let me try to find here the chain. The legacy one. Here I have a user profile, and I need to send the user a notification. But the type of the notification depends on the user configuration. If the user has enabled SMS, if the user has enabled email, or if the user has enabled past updates on their Google Wallet. So it's all configured in the user profile. Okay, so if you go here to the user profile, they have these three properties. And when I go back here to my chain implementation, I'm going to create a chain, and the chain is this one. I have a Google Wallet pass update notifier, which is the first option if the user has enabled it. The second option is the email notifier, and the third option is the SMS notifier. Instead of implementing multiple ifs, and every time I have to change add another implementation, I have to add a type and change the if code. I'm going to implement a chain of responsibility. How does it work? Well, I create an interface called user notifier with two methods, notify and set the next notifier, which is the next one in the chain. Then I have an abstract one, which just accepts the next notifier. Then let's implement this one. The Google Wallet pass updates. First, it does this. Profile, does it have Google Wallets enabled? If so, notify the user. Else, I wasn't able to notify because the user doesn't have Google Wallets. Then try the next one. If you have a next one, call the next one in the chain. If you don't have the next one, well, you have an issue because you weren't able to notify the user. So that's how the chain of responsibility works. So it's a lot of code for a simple logic, right? And you can see that in the next one, in the classic implementation, email notifier. Can you see a pattern here? Doesn't the code look the same? The SMS looks the same as well. What is the part that changes? Well, the part that changes is this. This is the actual useful implementation. Okay? I'm just changing the string. This is the actual useful implementation. What else changes? Well, the test. If this particular notifier applies to the particular context. How can we do better with this? So I'm not going to live code this one. I'm just going to show the modern version. Two different ways. Oh, sorry? Yes. So you have two different ways of implementing that, and I'm not certain of which one is better, so I'll let you decide. You can create, instead of having all that particular implementation of chain responsibility, you get your implementations of the notifier to implement two separate interfaces. You implement a consumer, because you're going to consume the profile and do the notification, and you also implement a predicate to test if this particular notify applies to the current user profile. Okay? So you can either implement both interfaces, or you can create a record which receives, well, those interfaces, which receives a predicate and a consumer of the user profile. Both implementations are valid. I didn't decide which one would fit better. So instead of, and the logic that goes through the chain, here, on the legacy one, you have to implement it in each one of the links of the chain. So you're copy-pasting a lot of code. In the revisited one, what do you do? Well, you use a Java stream. So what do we do here? We create a stream. The first version is by implementing the interfaces. I create a stream of the pass update notifier, and you can hear, well, I decided to change the order. My first option is to always send an SMS to the user. The only place in your code that you need to change to be able to achieve that change is changing the order here. Well, it's working everywhere in the system. Okay? You don't, I don't need to know where did I set the next notifier. No, you change here, it's already implemented. But suppose that this is the original order, Google Wallet, SMS, and email. So I have the chain implemented here. It's much easier to see what's happening. Then, first, you do the test. Does the link in the chain, is it able to handle my user profile? You do end.test user profile. For them, you find the first one that accepts, and if it's present, you call the accept method on the consumer interface. Okay? This is the modern way of you to implement the chain of responsibility pattern. The other version, what is? Well, instead of creating these classes, implementing those interfaces, you can just instantiate the record, new user notifier, and implement here. If, for example, for SMS, if the user profile allows SMS, well, I want to print SMS sent. You would probably have a method reference here to the implementation that sends an SMS. So I'm not sure which one is better, but note that here, on this particular implementation, you have to call the user notifier .predicate.test, and here you have to call u.consumer.accept. And here you can call the accept and the test method directly. So I'll leave it up to you. Which one do you think it's a better implementation of the chain of responsibility? So you don't have to keep implementing those multiple ifs and creating multiple types for every time you need this particular logic. You want multiple handlers, and the first one to succeed, you want to finish the processing. This is a chain of responsibility. Okay? And it's very useful because most systems these days, they have to send notifications. So I think it's going to be used in some of your projects. Next one, visitor. I don't know how many of you have implemented a visitor in real life? Very few. How many of you implemented just because you wanted to, not because you needed to? That was my case. When I read the book and I finally understood what a visitor does, the next day I was just trying to find a problem in the code base so I could implement the visitor. And I didn't need it. But I said, oh, this particular code, it might change in the future. So we're going to create a visitor here just in case. Why is that? Because I wanted to show to my colleagues that I was super smart, right? Okay, let's implement a visitor. Why is that? Because nobody understands what a visitor does, right? So let's implement this one, so I can think that I'm smart. Actually, it's a very dumb thing because then every time you need to, if people don't understand your code, when there is an issue, who's the only person that needs to fix the bug? Yeah? You. Yeah? Unless you quit before. Okay? So how can I implement the visitor? Well, the traditional problem that you're trying to solve with a visitor, let me try to find it here. Visitor. So my implementation here. So the problem usually is that I have a hierarchy, I have a Google Wallet Pass, I have a loyalty card, I have an event tickets. And I want to implement it in a different way. Suppose that I want to, what is the name of the method that I use here? Actually, I think we're almost out of time. So I'm going to skip the live coding and I'm going to just show you the code. Traditional visitor works like this. I have an abstract class and I create the method accept. And the reason for doing this is because when you have a class and you want to implement a strategy, usually visitors comes from multiple implementations of strategy. Because I have a wallet pass, I have a public void do one. And abstract do one. And I implement do one in all the subclasses. Then, I have another operation that varies on the type. So you create public abstract void do 2. And then you have another operation that varies on the type, do 3. So the traditional code is you create multiple strategies on the same hierarchy. And very soon, your code will be too polluted for you to understand. Because you have like a domain class, Google Wallet Pass, and you have multiple logic that you don't know even who's calling. And remember, cohesion and coupling, your cohesion and coupling, they improve if the code that you're using is closer to the place where it's being called, right? But if you do it this way on your domain object and you implement do 1, do 2, do 3, do other things, very likely you have another module, another part of your system that is processing something. You're implementing the code there, and then, I need to vary by type. You go to the other package in the other type of your side of your system, you implement that method there, and you call it here. So it's a maintenance hell. You increase the coupling between your modules. So it's a much better alternative for cohesion. If you're typing your you're implementing this part of the system. Oh, I need an operation that varies by type. And you create that code in this package, not in the domain objects. Okay? So for you to be able to avoid that, you need a visitor. That's why you would implement a visitor. You have multiple operations that vary by the type that you're applying to, but you don't want your code to be in that class that is away from you. You want the code to be close to the logic that you're implementing now. That's why you implement a visitor. So instead of doing these multiple strategy implementations, you do what? You create just one method, accept a visitor, and for each one of your concrete implementations, your method does this. Visitor.visit this. Who is this? This one. So it's just overloading. You have a visit that accepts a loyalty card, and you have a visit that accepts an event ticket. And when you're coding your business logic that varies by type, you create you have the type. In this case, we know it's a loyalty card, but because it's coming from the database or somewhere, I just type card.accept, and I create a visitor. And here I have the business logic. Well, if it's a loyalty card, do this. If it's an event ticket, do that. Okay? So when you need to vary your implementation, just like a strategy, but you need to vary it multiple times depending on what you're doing, and your logic is spread through your system, you want a visitor. The problem with a visitor is that it's a very ugly syntax. But the benefit of a visitor as well is that if somebody decides to create a new class generic pass, extends Google Wallet's pass, well, it doesn't compile because you need to implement the methods. You need to do this. You need to copy this implementation. So the benefit of the visitor is every time you add a new implementation, the code does not compile if you don't go through your source code base and add the visitor implementation in all of them. That's the beauty of the visitor. It prevents you from breaking the rest of your system. So for this to be able to compile, you will need to add this particular method, visit, generic pass, and now this visitor implementation is broken. You need to visit this one to make it work. So this is the advantage compared to the other disadvantages. What is the revisited way for you to implement the visitor? Well, in Java 20 Plus, you don't need to create visitors anymore because we have pattern matching. So you can create, and better than that, we have sealed classes. How does it work? The traditional one would be just public abstract class and abstract class, you would finish here, loyalty extends Google Wallet Pass, event ticket extends Google Wallet Pass. And then for you to be able to vary the operation, instead of doing multiple instance office, because it's just a bad practice, you would do with pattern matching. You would returns, you switch on the type. Just in case it's loyalty, well, you could use the default one, or you can use the lambda. Just in case it's loyalty, return 3. In case it's event tickets, return 2. But the problem is that you would always need a default 1, and you wouldn't need to return 0, for example. Okay? But then, if somebody creates a new type, you won't have a compile time error, okay? Which is a problem. How do we solve that? With Java 20, we can use sealed classes. So Google Wallet Pass can become a sealed class. When you have a sealed class, you have to say, well, the only permitted implementations are loyalty and event tickets. If somebody decides to do what? Generic pass, they need to add it here. And if it's a sealed class, you don't have problems here anymore because your list is always exhaustive. You're never going to reach the default one. Most people, when they're doing the default, they would do this. Throw new runtime exception. It's not going to happen. Yeah, because I covered all the cases, and then instead of a compile time error, You have a runtime error, which means you coded the logic today, and it's going to blow up 2 months from now. Because, oh, this case wasn't supposed to happen, but it happened. Because you forgot that you forgot to cover all the cases because you added an additional type. But if you have sealed classes, you don't need default anymore because it's restricted. And if you want to create a new one, final class, generic pass, extends Google Wallet pass. Well, you have a compile time error because it's not covered here in the permits. Well, permits, generic pass. And now what happens? Your switch doesn't compile because you have to cover all the cases. Case, generic pass, return 3. And another, this is just for Java 20. If you're using Java 20 Plus, you can use pattern matching not only on the type, but you can use pattern matching also on the state of the type of the object that you're receiving on the switch statement. How does it work? Suppose here that loyalty has a property called size. And I can say, well, case loyalty. But I can say, well, case loyalty case loyalty dot, actually, let me get when. Perfect. When L.size greater than 10, you do return a 5. And I could do this, case L greater than 20, and you have an error. Why is that? Because this case is never going to happen. Because the compiler doesn't know, but because if it's bigger than 10, it's also bigger than 20. So if you want to cover this one, you have to reorder this. Okay? So the compiler is smart enough to know if it's exhaustive, if it's an unreachable code, and now you can also test based on the state of the instance. What else? Specification, this is the last one because we're almost out of time. And specification, just going to show you. Sometimes when you're creating queries or conditions in your system, it's very common for you to, it was in the past, for you to give meaning to some stuff. So, in the past you would have to implement an interface, specification is satisfied by, this is from the domain-driven design book, okay? And you create implementations for and, for or, and for not. For the revisited version, you don't need to do that anymore because you already have an interface which implements all the cases, which is predicates. And if you want to give meaning to something, what would you do? Well, you want to test if it's a credit card. Well, you could do this. Well, you could test the length, 30 if it is 16. Well, you call it write length, and you give a lambda. You call it is numeric. Well, if it matches the only digits. And then if you want to create a new condition, a new predicate, you just say potential credit card number, it's write length and is numeric. So instead of having magic tests in your code, now you're giving name to those conditions. So it's much easier for you to understand what's happening. Well, potential credit card number, it's only true if it's the right length and numeric. Your code is much more readable. So that's why you would choose to implement, to use a specification. And of course, if you ever created, I used to create specifications in the past to be able to build queries for multiple different languages. Like I want to create queries that worked just as well and in XQuery, if anybody remembers what is that, and SQL. So we created specifications with different implementations. Most likely you don't need to do this today, but it's still nice for you to have this readable code in your code base. Okay? And this was the last one. If you want to learn more, of course, all the code that I'm showing to you is available on my GitHub, /Yanaga /revisiting design patterns. And I'll let you take a picture. If you want to take pictures of me on poster Twitter, I accept them as well. And shameless plug. If you want to learn more about Google Wallets, okay, you can go to this URL, developers.google.com/wallets. And thank you so much.